Hi students, in this video we are going to discuss about dispersion of light. Now the phenomena of dispersion was discovered by Sir Isaac Newton. He said white light is composed of 7 colors, the Vibgyor colors, and he explained it with his famous experiment of a prism. Now what he did is, he took a prism, made white light incident on the prism, and on the other side of the prism a screen was kept. Now we observed that the white light which was sent through the face AB of the prism, when it reaches the screen, it is split up into 7 colors, and thus he said that white light is made up of 7 colors. And the process of splitting of white light into 7 colors, into its component colors, is known by the name dispersion. The process of splitting of white light into its 7 colors is known as dispersion, and the band of colors which we obtain by dispersion is known as spectrum. Spectrum means a range of, in this case, a range of colors. Now what creates dispersion? We know white light is made up of 7 colors. So each color will be having its own wavelength. The range of wavelength of visible light is from 400 to 700 nanometer, in which violet is having the least wavelength of 400 nanometer approximately, and red light is having the wavelength of violet light is having the wavelength of 400 nanometer, and red light, a range of its wavelength is from 680 to 720 nanometer. So what creates dispersion when light passes through a prism or when light passes through a refracting medium? Dispersion takes place because the refractive index mu of the refracting medium is different for different colors. The refractive index mu of the medium for different colors is different, or in a sense it depends on the wavelength of the color. Now the relation between the refractive index and wavelength is given by the relation known as Cauchy's relation. And is given as mu is equal to A plus B divided by lambda square plus C divided by lambda raised to 4, where A, B, C are constant which depends on the medium. And lambda is the wavelength. So from this relation it is clear that the refractive index is inversely dependent to the wavelength of light. So mu is inversely dependent to the wavelength. So greater wavelength means lesser will be the refraction. Now the relation between angle of deviation and refractive index is given by delta is equal to A, which is angle of prism, into 1 minus mu. Delta is equal to deviation, extent of deviation is equal to A, angle of prism, into 1 minus mu, where mu is the refractive index. And we also know that refractive index depends on wavelength by the equation A plus B divided by lambda square plus C divided by lambda raised to 4. Now, if you look into the diagram, it is clear that the red light is getting deviated less when compared to the violet light. Now, why is the deviation of red less than the deviation of violet? It is a question asked by the board. It's a short question. Why is deviation produced in red light less than the deviation produced in violet? Now, we know the refractive index of the medium, refractive medium, is inversely proportional to the wavelength, isn't it? And wavelength of red light is greater than wavelength of violet light. This is having 400 nanometer wavelength. This is having 700, approximately 700 nanometer wavelength. So, wavelength of red is greater than wavelength of violet. So, what happens to refractive index? Therefore, refractive index of red will be less than refractive index of the medium for violet light. And also the dependence of refractive index with deviation is mu is equal to A into 1 minus mu, which means direct relationship. Mu is proportional to mu, we can say, which means deviation produced in red will be less than deviation produced in violet light. I hope this is clear to you. Wavelength of red is greater than wavelength of violet. So hence, according to Cauchy's relationship, refractive index of red by the medium will be less than refractive index of violet, and hence the deviation produced in red light will be less than the deviation produced in violet light. Thank you.